Hello, I'm Joseph Kasser, and welcome to this podcast where the AI team does a deep dive into some application of systems thinking.
Welcome to our deep dive into the world of systems engineering competency.
Oh, yeah.
And you've given us a really interesting paper to start with.
Yeah.
A framework for benchmarking competency assessment models.
Mm-hmm.
So let's unpack what it really takes to be a top-notch systems engineer.
Well, you know what's funny is we all use systems engineered products every single day.
That's true.
But most people wouldn't know a systems engineer if they were standing right in front of them.
It's so true. And it's kind of what makes us so interesting. We're going beyond just the job title and into what makes someone skilled in this field. From what I see in this paper, it's not just about knowing the technical stuff.
Yeah.
It's how you think and how you actually apply that knowledge.
Absolutely. And that's where things get really interesting.
Yeah.
The authors of this paper, Joseph Kasser, Derek Hitchens, Moti Frank, and Yang Zhao, actually break down 9 different competency models.
Okay.
Each with its own approach.
9. That's a lot.
Yeah.
Can you give me an example of 2 that are very different?
Oh, sure. Absolutely.
Yeah.
So imagine you're trying to figure out if someone is a good cook.
Okay.
One way to test that is to just test their knowledge of recipes and techniques.
Right.
That's similar to what the KSA's or knowledge, skills, and abilities model does.
Okay, so like a systems engineering pop quiz.
Exactly.
Yeah.
But another approach would be to watch them in action.
Okay.
See how they handle problems.
Right.
How they adapt recipes, how they manage their time.
Yeah.
That's more like a CES model, or capacity for engineering systems thinking.
Oh, wow. So one is what and the other is how.
Exactly. And this paper explores a whole spectrum in between,
Okay.
including models from INCOS, NASA, even the Department of Defense.
Wow.
So there's no single definition of what a competent systems engineer is.
Well, that makes sense if you think about it.
Right.
Like, someone working on a NASA rocket launch needs different skills than someone designing a new smartphone app.
Exactly. And the authors acknowledge that this role has been evolving for decades. It used to be more about planning and designing systems, but now there's more emphasis on interpersonal skills and teamwork and navigating complex implementations.
So how do we even begin to compare these apples and oranges?
Well, that's where the authors propose their solution. The Competency Maturity Model Framework, or CMMF.
Okay.
Think of it as a universal translator for competency models.
Okay.
It helps us understand how different models relate to each other, and most importantly, where the gaps are.
Wait, gaps like things that are missing?
You got it. And one of the biggest gaps they highlight is this thing called the implementation domain.
Okay.
It's the step of turning a design into a working system in the real world.
Okay, so like having an architect who designs a skyscraper,
Yeah.
but completely forgets about plumbing and electrical wiring.
Exactly.
You can have the best blueprint in the world, but if you can't actually build the thing.
Exactly. And what's interesting is that none of the 9 models really addressed this implementation gap. Yeah. It's almost as if there's this assumption that if you're good at the theoretical side,
All right.
the practical side will just fall into place.
Which, based on my experience with some DIY projects, is not how it works.
It's definitely not.
Yeah.
And this has some pretty big implications, especially when you're thinking about high-stakes projects in aerospace, defense, or healthcare.
Right.
Because this lack of competency can lead to costly delays, design flaws, and even safety risks.
So this CMMF, this universal translator,
Yeah.
what does it actually do to address these gaps?
Well, imagine a graph.
Okay.
On one axis, you have categories of competency: knowledge, cognitive characteristics, and individual traits.
Like the building blocks of a skilled systems engineer.
Exactly.
Got it. So what's the other dimension?
Competency levels.
Oh, okay.
From apprentice all the way up to master.
I like the sound of master.
Yeah.
So this framework isn't just about comparing models. It's about seeing where someone is on the competency spectrum.
Precisely.
Like, are they a beginner or are they someone who can tackle the toughest challenges?
Exactly. And the CMMF recognizes that people can move through these levels.
Oh, okay. So it's not a fixed label. You
Right.
could be a master in one area and an apprentice in another.
Exactly.
Okay.
And the CMMF encourages us to think about how we can help engineers progress,
Okay.
giving them training, mentorship, opportunities to reach their full potential.
So we've talked about these competency models, this universal translator called the CMMF,
Yeah.
and this gap in the implementation domain.
Right.
There's definitely more to being a systems engineer than meets the eye.
Absolutely. But before we move on,
Yeah.
what aspects of systems engineering competency are you most interested in exploring further?
That's a great question, and one we'll definitely delve into
Okay.
as we continue our deep dive.
Sounds good.
As we're diving deeper into these competency models,
Uh-huh.
it really strikes me how much emphasis there is on systems thinking.
Yeah.
It seems like that's the bedrock of everything else.
It absolutely is systems thinking, is that ability to see the big picture, understand how all the pieces fit together and interact.
And that's probably where that analogy comes in of problem formulators versus problem solvers
Exactly.
to illustrate the levels in the CMMF.
Yeah, a problem solver may be great at tackling individual tasks,
Okay.
but a problem formulator can analyze the entire system
Right.
and figure out the root cause of the issue.
So they're not just treating the symptoms.
Ex-
They're going to the source.
Yes.
Which makes me think about the implementation domain gap
Yeah.
we've talked about.
Oh.
If someone is really strong in systems thinking,
Right?
shouldn't that mean they're good at bringing a system to life?
That's a great question, and the paper actually tackles that.
Okay.
While systems thinking is a good foundation, it's not enough on its own.
Okay.
You also need specific knowledge and skills related to implementation.
So it's like having a brilliant strategist
Yeah.
who can make a perfect battle plan but has never actually been in battle.
That's a great analogy. The CMMF wants us to think about competency in this multifaceted way.
Okay.
You need that theoretical background,
Uh-huh.
the problem-solving skills,
Yeah.
and the practical know-how to be good in the implementation domain.
Can we get a little more concrete?
Oh, sure.
What are some skills that would fall under that implementation domain?
Let's say you're designing software.
Okay.
Understanding the software development lifecycle is important.
Right.
Knowing how to write clean code, manage version control, implement testing.
So it's not just knowing the programming language. It's
Right.
knowing the whole process of building a reliable software product.
Exactly. And those skills are very different from a computer science degree.
I imagine it goes beyond the technical side as well.
Absolutely. Think about the social and organizational factors during implementation.
Okay.
You need to be able to communicate with different teams.
Yeah.
Manage expectations.
Uh-huh.
Navigate roadblocks.
So it's like a conductor
Yeah,
who understands the music but also leads the orchestra.
that's a great analogy.
Yeah.
The implementation domain is where all the different instruments come together.
Right.
The technical, the social, the organizational.
To create something amazing.
Exactly.
And it seems like that's where competency models fall short.
It seems that way.
Yeah.
They focus on the individual notes, but not the whole symphony.
Right. And that's why the CMMF is so valuable. It gives us a way to find those missing pieces
Right.
and build better models that prepare systems engineers for implementation.
Yes.
But let's be realistic here.
Sure.
Building these models is one thing. But how do we know if someone...
Like portfolio reviews or simulations.
So they can actually show what they can do,
Right.
not just tell you what they know.
And the paper even suggests interviews.
Oh, okay.
Focus on past experience
Oh, interesting.
and problem-solving approaches.
Yeah.
It's about how they think and apply those skills.
Oh, okay. That makes sense.
Yeah.
But assessment is just one part.
Mm-hmm.
How do organizations actually develop competency?
You're right. You can't just wave a magic wand.
Right.
The paper really emphasizes that this should be part of the organization's culture.
Okay.
Provide learning opportunities,
Yeah.
mentorship, and professional growth.
So they need to be able to learn, experiment,
Yes.
even make mistakes.
Competency development is a journey, not a destination.
And even experienced engineers can still learn and develop.
Absolutely.
Speaking of experience,
Yeah.
the paper talks about cross-disciplinary learning.
Right.
Systems engineers can benefit from other fields.
Yes, especially fields that focus on people.
Okay.
So if you're designing a medical device...
Yeah. It's not just about the technical side. It's about how people use it.
Right, like the patients and the doctors and nurses,
Exactly. And those insights can come from psychology, sociology.
even anthropology.
Yeah.
It's about giving the systems engineer more tools
Absolutely.
than just technical skills.
And the paper highlights how organizations can do this.
Okay.
They can create collaborations, encourage more education,
Okay.
or just foster a culture that values different perspectives.
So it's about this holistic view of systems engineering
Yes.
that recognizes all the different parts and how people are important too.
Exactly. And that brings us to another idea from the paper.
Okay.
Assessing competency shouldn't just be about the individual engineers.
Okay.
It should also be about the processes.
So not just the people, but how they work together.
Think about it like this.
Okay.
Even the best musician can't make good music
Right.
if their instrument is out of tune.
Yeah.
So even good engineers can be held back.
By bad processes. Yeah, or a lack of support.
So we have to look at the big picture and
Rough zone.
ask if our systems and processes are actually good.
Exactly, and we can use the CMMF to do this.
Really?
Yes, by looking at the knowledge, characteristics, and traits.
We can see where the strengths and weaknesses are.
That's right. It's like a checkup for the organization.
Yeah, are we
Yeah.
doing things the right way?
Exactly, and this shouldn't be a one-time thing.
Okay.
It should be continuous.
So constantly improving.
Yeah, using data and feedback and lessons learned.
Right, so we're refining and optimizing.
Yes, and the paper says we should involve the engineers in this too,
Oh, that's interesting.
because they're the ones using these processes.
That's a good point. So it's about empowering them
Yes,
to shape their own development and the practices of the organization.
and that leads us to another question.
Okay.
How do we measure the impact of all of this?
Yeah, it's like we're trying to solve for X in some crazy equation.
Right.
You have individual competencies,
Uh-huh.
organizational processes, and then the impact on the actual projects.
Exactly, and the paper really highlights this.
Okay.
It says we can't focus on just one of these things.
Right. We have to look at the whole system.
Yes, from the skills to the culture to
They,
really see the impact.
So how do we even connect those dots? How do we know if it's working?
That's the big question, right? And the paper has a few ideas.
Okay.
One is to track key performance indicators or KPIs.
Okay.
Like, are projects on time and budget?
Okay.
Are there fewer defects?
Right. Those metrics can tell us something.
Exactly. It's about going beyond checking boxes
Yeah.
and looking at real-world outcomes.
Are we building better systems?
Yes. Are we delivering value?
And the paper also says we should get feedback from stakeholders.
Oh, absolutely. That's important.
Okay.
What do they think of the quality?
Right.
Are they happy with the process?
So it's almost like a feedback loop.
Yeah.
We invest in competency.
Uh-huh.
We measure the results.
Yeah.
We get feedback.
And then we use that to improve.
Right. Constantly refining and optimizing.
Exactly. A culture of continuous improvement.
Yeah. Where competency development never really ends.
That's right.
It's an ongoing journey.
Yes.
Which brings us to the call to action from the authors.
Yeah.
They want us to embrace this holistic approach,
They do. And I think that's so relevant now.
especially with how complex these systems are becoming.
Absolutely. We can't just rely on old models and technical skills.
So competency is an investment, not an expense,
Exactly. Investing in engineers can pay off big time.
in terms of project success and innovation.
Absolutely a more adaptable organization, too.
Well, this has been a very insightful deep dive.
It has been.
We've covered so much.
Yeah, we talked about the models and systems thinking and that implementation piece.
But before we go, I want to bring it back to you, the listener.
Yes, think about your own journey with competency.
What are your strengths as a systems engineer?
Yeah. Where do you see room to grow?
And how can you use what we've talked about today to get better and make a real difference?
Remember, competency development is a process.
It never really ends.
There's always something new to learn.
A new challenge.
Keep learning, keep growing.
And keep striving to be the best systems engineer you can be.
Thanks for joining us on this deep dive.
We'll see you next time.
I hope you enjoyed today's deep dive. Why not take a moment and join the discussion in the LinkedIn group Tackling Complex Problems. Take care.